You know those math problems? The ones that just seem impossible? The ones that make you want to fill up a whole page with messy algebra? Well, some of them have a secret, a visual shortcut that's so simple it almost feels like cheating. And today, we're going to uncover one of those secrets.
I mean, we've all been there, haven't we? You're staring at a word problem and the numbers and words just kind of melt together into a blur. You have no idea where to even start. It's that classic feeling of being totally and completely stuck.
Okay, so take this one for example. It's a classic mixtures problem. You've got one metal alloy that's 15% copper. You've got another that's 65% copper. So the puzzle is, how much of each do you need to melt down and mix together to get exactly 200 grams of a new alloy that's precisely 30% copper? It sounds more like a chemistry experiment, but it's a math problem that can really make your head spin.
And hey, if this kind of thing makes your brain hurt, you are so not alone. Turns out, according to surveys, a whopping 67% of high school students, that's 2/3, really struggle with these exact kinds of problems. So if your first instinct was to panic and reach for a complicated formula, you are in very good company.
But here's where it gets really cool. What if I told you we could solve this without all that messy algebra? I mean, let's just toss the old playbook out the window for a second. What if, instead of calculating the answer, we could just draw it?
To do that, we have to look at the whole problem a little differently. We just need to get our heads around one core idea and think about it in a new way. And that idea is concentration.
Now, don't let the word scare you. All concentration really means is how much of one thing is inside of another. It's just a percentage. So when we say an alloy has a 15% concentration of copper, it literally just means that for every 100 grams of that alloy, 15 grams are pure copper. That's it. Nothing more to it.
Okay, now for the fun part. Let's turn this idea into a picture. Imagine any mixture, like our alloy, is just a simple rectangle. The width of that rectangle? That's the total weight of the mix. And the height? That's the concentration, the percentage. Which means the shaded area you see here, that's the actual amount of the pure stuff, the copper in our case. This is the whole idea behind something called the rectangle method.
And check this out. If you want to mix two different alloys together, you just add their rectangles side by side. How cool is that? All of a sudden, this abstract math problem feels totally real, right? You can actually see what's happening. So once you start thinking visually like this, it opens the door to some seriously powerful hacks for solving problems. And this isn't just for homework, you know? It's a great way for anyone to get a better, more intuitive feel for numbers. Now that rectangle method we just looked at is awesome for really understanding the concept. But there's an even faster way, a more elegant shortcut for getting the answer directly. It's often called the cross method. So let's put it to the test. We're going to take that original problem that looked so intimidating, and I promise you, we are going to solve it in like under a minute. No complicated equations, just a simple drawing. Okay, here we go. First step, we just draw a simple grid, almost like a tic-tac-toe board. Think of this as our canvas. This is where the magic is about to happen. Now we just start plugging in our numbers. On the left-hand side, we put the concentrations of the two alloys we're starting with, so 15% and 65%. Then, right there in the middle, that's our goal. That's the concentration we're trying to end up with, 30%. Okay, everything is in place. All the information is on our little grid. So get ready, because this next step, this is the simple little trick that unlocks the entire problem. All we have to do is subtract across the diagonals. Always the bigger number minus the smaller one. So look at the first diagonal. We take 65 and subtract our target of 30. That gives us 35. We write that on the top right. Now for the other diagonal. Our target, 30, minus 15. That gives us 15. We pop that on the bottom right. And believe it or not, all the hard math is already done. So the big question is, what do these new numbers, 35 and 15, actually mean? They're not just random numbers. This is the punchline. This is the exact ratio of the two alloys that we need to mix together. So the ratio is 35 parts of the first alloy to 15 parts of the second. And 35 to 15, well, that simplifies right down to 7 to 3. This means we need 7 parts of the first alloy for every 3 parts of the second. Since we need 200 grams total and 7 plus 3 is 10 total parts, each part must be 20 grams. So 7 parts is 140 grams and 3 parts is 60 grams. And just like that, there's our answer. No messy algebra needed. Now this is an awesome trick for a math problem, but it points to a much bigger idea. Why? Why is a simple little drawing sometimes so much more powerful than a long, complicated formula? There's an old saying that goes, "You can't be taught, you can only learn." And I think that nails it. An algebra formula, that's like someone just telling you the answer. But a visual tool like the cross method doesn't just give you the solution. It actually gives you a way to see the relationships yourself, so you can build the answer from the ground up. So why are visual methods like this so darn effective? Well, they're basically translating abstract algebra into a language our brains were built for. We're visual creatures, so instead of juggling a bunch of abstract variables in your head, you can just see how everything is laid out. It just matches our intuition about how things should balance out, and it makes the connections between the numbers totally obvious. Which leaves us with a really fascinating thought, doesn't it? This was just one type of problem, but how many other complex challenges, in math, in science, maybe even in our daily lives, are just sitting there, waiting for the right picture to make them simple? What's the next impossible problem that's really just a drawing in disguise?